this is kind of what I was playing with so Fusion. I figured a nice background because I didn't get around to making slides, so you can just watch this. You can change the prompt. There's someone back here that's changing the prompts as I'm talking, and who knows what I'll see here. But it's dynamically creating images at like 6 frames a second, right? And this is so beyond the capacity of running, it's just running on one little computer, well, big computer, whatever, but it's so beyond the capacity of web. And I started getting into it, like, where can we go with here, right? And so we always talk in CosmWasm about Cosmos. Cosmos, IBC, CommBFT, SDK. There's another part of CosmWasm. It's called Wasm, right? And I think the more I got into this and reflected, the more I'm like, why can't we bring Wasm out? Because Wasm brings most of the cool things we have in CosmWasm about being able to deploy code on other people's computers safely, sandboxed, about being able to upgrade running code deterministically, to coordinate multiple people running exactly the same stuff. That's Wasm, right? And imagine running stuff like this in Wasm. You can run anything in Wasm, right? There is this. So I really started digging into Wasm, and this is like the last month. This just May. So I really started digging into Wasm and what Wasm can do. And it's far beyond what it was in 2020 when building CosmWasm. So I'm going to give you a little overview of some really cool things in this Wasm Wonderland. The first thing I think is amazing is the thing called, basically there's a whole system called WASI, WebAssembly System Interface. And that has turned into this whole system of things. And WebAssembly components, component model, Wasm component model, there's lots of tools around it. So I'll just give a brief overview of that. And if you want to learn more, come to me and talk. All right? So the basic idea is you can run, like we have contracts, these things called components that actually have clear typefaces. They're typed, they have a type with them, all the exports, imports, all the messages they have, along with actually the code together. And you can wire them together. All these tools are basically taking them, know what you have, you wire the inputs and outputs, and you can connect these things in very compilation time things. It's great for compiling, really type safe. And they often allow you to do complex types into now of Wasm, which is something, if you looked inside of Wasm VM, CosmWasm VM, there's lots of really low-level, C-level stuff, copying pointers of memory and data structures from the host into the Wasm and back. If you ever looked at this stuff, it's kind of gnarly. It works really well. And thank you, Simon, for making sure that works really, really well and has no memory leaks. But it's really nasty stuff, and this just happens. So you can do complex data structures. You can communicate really quickly between these components. But what can you do with that, right? You can wire them in, and it's super easy now to embed custom embeddings into hosts. What can you do with that? So WebAssembly System Interface explains how to expose file system, network access, random number generation, CLI, output, everything there. They're working on threads into that. So you can actually write Wasm, sandbox, and say you can access these two sites and this file, the directory of the file system, and nothing else. But compiling normal Rust code or Go code into Wasm and running there, which opens up a whole door, right? Opens a door. There's this project called Spin. So like, I'll just give you a few pieces and explain what you can do with this. Spin is a really cool project. It basically allows you to upload WASI, not upload it. You have to make a config file, but you write a config file, and that just picks which WASI you have, and then it just runs on it. So, okay, HTTP trigger this, run this. So you upload serverless functions more or less. And you can write your custom runtimes for it, you can extend it, but it's an idea of basically taking arbitrary stuff. Wow, nice. Taking arbitrary stuff and allowing you to upload arbitrary WebAssembly, and it can access the internet. It can access Redis. It can access Postgres. They've combined all these bindings, so you can actually build a real web app with a bunch of little components, which you can upgrade and swap at time. Each one sandboxed to small environments. And so I started thinking with that, what can you build? What can you build, right? So imagine really trying to build decentralized infrastructure. People try this for a while. Like Akasha's been around for a while, infrastructure. We have all of the on-chain stuff. What's the off-chain stuff? How do you deploy that stuff? They try Docker, running VMs, it's not really secure. How about running and just deploying sandbox WASI on hosts, right? They're safe. They don't need to worry about what you're doing on it. They just run this very sandbox thing. Okay, you can talk these 3 network calls and this. I put a CPU limit on your code, and that's it. Even gas on it. They can run, you can upload arbitrary code. They can be secure, it's there. You can run it on 3 or 4 different people and even verify it, get consensus, right? Like actually I'm gonna run on 3 people and make sure they're all agreeing. So it can do super lightweight. You can start building really the idea of decentralized infrastructure. You can build normal web apps on it, You can build backends on it, and then you can distribute that on decentralized infrastructure. You can upload it just to declare, okay, you can even have a registry on chain saying, hey, to run this code base, I want to upgrade my stuff. I have the DAO vote to change the official running of the off-chain process, and it just gets upgraded everywhere else. So these ideas of being able to bring the upgradability, the composability, the reliability of Wasm into off-chain infrastructure is pretty cool, and it's being worked on by many, many people. Lots of big companies working on this. All these standard like Wasm components. This is Spin even there. It's this huge project of lots of big companies doing that, and they're funding all the fundable stuff. Like Wasm VMs was built by a bunch of big companies too, right? There's lots of money in it. All the Rust tooling for it, all the tooling to make it work well is really funded. So this is something we can just take and build on. It goes beyond that though. You can use Wasm for UIs, right? Have anyone played with these things, building like UIs in Rust? Nice. It's kind of cool, right? You can write Rust and it just renders, right? It runs actually WebAssembly in the interface, and it just renders basically HTML DOM changes. So you have a binding that says, okay, we're going to do all the logic here, and we write out the new HTML, and that's just rendered on the web interface. Then there are projects like Deoxys, which allows you to actually like native desktop apps in Rust, right? It looks kind of like the React approach, but renders native desktop apps. And you can imagine running that one. And you can imagine then loading a WASI blob to like actually have full file system access or full network access on there. And you could have now saying, okay, we have these shims that connect to the web or connect to the desktop and run this like Wasm blob, which you could upgrade safely. And you can vote on this Wasm blob. And by having that, your only trusted surface area is actually like the bindings to your browser, right? And what the WASI is doing cannot violate anything. So you can actually say basically, we have this small area that's consistent that binds the UI and connects to the world, and then you can just throw new Wasm up there. You can upload new Wasm. So I think the idea of having like these small sandbox things that have all the business logic that you can just swap out over time allows you to deploy like these things and really quickly deploy upgrades on components securely and safely. So now imagine putting real business logic in there. So it's not just the UI, but it's actually kind of the server embedded in the clients. And then you start networking these things together. Right? So with these new interfaces, you can actually start like deploying code on hundreds of machines and network them up. And one reason that peer-to-peer technology never took off, really, is legally, they busted it. Like things like BitTorrent I'm talking about, right? And Tor, like one is there's legal attacks. And secondly, there's a really impossible upgrade. It's like Bitcoin. You can't upgrade it, right? It works. If you have BitTorrent, it still works 20 years later, 25 years later. It works, but they can't really upgrade the protocol because there's millions of machines out there running this old protocol, right? And everyone has to upgrade to get a new version, and it's really, really hard. Imagine when you went from Bitcoin to Ethereum, what happened? Suddenly you had this huge infrastructure of a blockchain that everyone can just deploy code to really easily and continually upgrade, right? This is a revolution in blockchain technology, the idea of smart contracts, the idea of being able to deploy stuff. And we bring it further with Wasm to be able to deploy much bigger things. Now, imagine you could have like a BitTorrent type thing, and you could actually just deploy new versions of the protocol, and everyone just automatically download new versions of the protocol safely, securely, without having viruses, completely sandboxed, right? Reliably distribute them through a blockchain, maybe with some DAO, with the signatures all signed there in a registry, download off some CosmWasm blockchain, and you can imagine start of like how you can actually build new apps, composable apps, deploy securely, and start building this infrastructure. So I got really inspired by these possibilities. There are a bunch of examples out there. And I see this as a new form of Wasm. Running the blockchains, running off-chain, running clients, running peers, connecting it all through Wasm. So your whole project isn't just, I built a contract and then I run to a JavaScript app which I deploy centrally on a server I run. But the whole side, and the indexer on some other server, and some other off-chain indexer here, and some other UI here, you'd actually have the whole thing on decentralized infrastructure running Wasm components, and your entire stack could be Wasm contractor, WASI indexer, Wasm-based UI, and the whole thing could be written out there and securely deployed across the whole stack. So this is what I'm working on. If you're interested in this, come talk to me later. I'm digging into deep WASI, all the off-chain stuff, and how it can integrate with the on-chain stuff, and really expand our whole horizons from that. I think this is opening up like new doors. There's this project called Spin, which allows you to connect a lot of this stuff. It's pretty cool. And I want to give a thanks to a lot of other people building tooling out here. So I started playing with tooling. Getting back into CosmWasm and seeing how to combine the contract with stuff like this. So there's a really, really cool tooling out there. There's also not exactly WASI, but I want to thank. So CosmWasm 2.0, it's cool to play with that one. Very happy to see Sylvia hit 1.0. And very cool to see CW Orchestrator, because I've been employing with that tool, and I think it's really, really powerful to really powerful to really get your deployment and testing the same kind of code. So actually getting stuff deployed and not having to figure out bash scripts anymore, super nice. So anyway, thank you all for building this tooling, and thank you guys for building this stuff. And I really want to expose, maybe next CosmWasm I'll actually show you a working demo with all this off-chain infrastructure. But now I'm building all these things on my spare time in my pieces. Come talk to me about them if you want to dig into it, or if you want to dig into AI stuff, because you can build all this stuff in Wasm. Welcome to Wasm Wonderland.